Good morning, dear children of class 8. Today we'll be learning types of chemical reactions. So you know now what is a chemical reaction. Chemical reaction actually is a chemical change in which one substance or more than one substances combines to form a new substance. So chemical reactions are of different types. The most common ones are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. So in our class, in class 8, we'll be learning only 4 types of reaction. They are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. A combination reaction now. A reaction in which 2 or more substances combine to form a single substance is called combination reaction. So what is a combination reaction? It is the reaction in which 2 or more substances combine to form a single substance. So what is the most important thing here to notice is, in a combination reaction, reactant can be of any number, but product has to be only one. There has to be only one product. There has to be only one product. Okay? There has to be only one product. Reactant can be of any number. That means the chemical substances on the left hand side can be of any number, but the product has to be only one. So then it becomes combination reaction. Then it becomes combination reaction. In the above reaction, the combination of substances A and B takes place to give a molecule of a new substance AB. So I think you understood now what is a combination reaction. A reaction in which 2 or more substances combine to form a single substance. So how many reactant can be in a combination reaction? Any, 2 or more. How many products can be there in a combination reaction? Only one. Only one. This is the specific characteristic of a combination reaction, that it can have only one product. So in combination, that this combination reaction can take place, can occur in 3 ways. Number 1 is 2 elements combine to form a compound. 2 elements, one element and another element. You can see in this figure here, magnesium is an element and oxygen is another element. Magnesium is an element and oxygen is another element. This magnesium and oxygen are combining to form a product. So here how many reactants are there? Only 2 reactants are there, magnesium and oxygen. But how many products are there? Only one product. Only one product is there. 2 reactants are there and product is only one. So this becomes combination reaction. So you can see here magnesium ribbon is there, and this magnesium ribbon is burnt with the help of matchstick. Then it burns with a dazzling white flame. Dazzling white flame, not the flame that is shown in the figure. It is not yellow, this kind of yellow or red in color. It is dazzling white flame. So this burns with the dazzling white flame, and the ash that we get as a result is white magnesium oxide, white powder, and this white powder is magnesium oxide. Got it? So 2 elements combine to form a compound. That means this kind of reaction is called synthesis. So what is synthesis then? Synthesis is a combination reaction in which two elements combine to form a compound. So this is also combination reaction only. All synthesis are combination reactions, but all combination reactions are not synthesis. Only that combination reaction in which the reactants are elements, then only that combination reaction is called synthesis. So magnesium is burnt to give magnesium oxide is a synthesis reaction, is a synthesis because two elements are combining here. Then more examples. Iron plus sulfur, both are elements. When heated together, iron and sulfur, when heated together, they form iron sulfide. Only one product, that is to be noticed, only one product. And the reactant here are both elements, so it is synthesis. Then similarly, carbon bonds in oxygen to form a gaseous compound, carbon dioxide. Here also, if you notice, carbon is an element, then oxygen is another element, which are combining to form carbon dioxide, only one product with the release of heat. So this is also synthesis. Of course it is combination reaction, but under combination reaction also this is synthesis. So what is synthesis, my dear students? Synthesis is a combination reaction in which both the reactants are elements, or in which reactants are elements and which combines to form a compound. Then number two ways in which combination reaction take place is when an element combines with a compound. One reactant is element, but the other one is compound. So element plus compound gives compound. Element plus compound gives compound. So this way also combination reaction takes place. Here you can see the example, carbon monoxide combines with oxygen. So carbon monoxide is a compound and oxygen is an element. So these two are combining to form carbon dioxide as a single product. So since there is a single product, so this is also combination reaction, and in this combination reaction one of the reactant is element and the other is compound. Then in the third one is both the reactants are compound. And these two compounds combine to form a single compound. So you can see here ammonia combines with hydrogen chloride gas to give ammonium chloride, which is a single product. Here ammonia is a compound because you can see elements in ammonia are different. So it is a compound, is a molecule of a compound, and hydrogen chloride is a molecule of a compound, and these two compounds are combining to form another compound. So how many ways a combination reaction can take place? In three ways. Number one is element plus element gives compound, which is also called synthesis. Number two, element plus compound gives compound. Number three, compound plus compound gives compound. So in this way combination reaction takes place. There are some more examples of a combination reaction. You can see here PCl3 plus Cl2 gives PCl5. First thing you have to notice is how many products are forming. If there is only one product, then you can be sure that it is a combination reaction, because in a combination reaction product cannot be two. Mind you, again, product cannot be two. There has to be a single product. There has to be only one product. So if this criteria is fulfilled, then you can go for the reactants. So PCl3 Here phosphorus atom is also there, chlorine atom is also there, so it cannot be an element, it is a compound. So compound plus chlorines, both the atoms of chlorine are similar atoms are there, so it is an element. Why we are writing Cl2 is because chlorine is diatomic element. So PCl3, phosphorus trichloride plus chlorine, gives PCl5, which is phosphorus pentachloride. So what kind of criteria, what kind of this type is there? This is compound plus element gives compound. Then second is compound plus compound gives compound. Sulfur dioxide is a compound, water is another compound, and sulfurous acid is a single compound. Then nitrogen pentoxide plus water gives nitric acid. This is also compound plus compound gives compound. This is also of type 3. Then number 4 is also type 3. Compound plus compound gives a compound. Then decomposition reaction. So decomposition reaction. So what happens in a decomposition reaction? In a combination reaction, two or more substances combines to form a new substance. Here all substance breaks into many substances. Just opposite of combination reaction is decomposition reaction. So opposite of combination reaction is decomposition reaction. In combination reaction, combines, okay, substances combines to form a new substance, but in decomposition reaction a substance breaks into two or more new substances. So that is the difference. So a reaction in which a compound breaks up on heating into two or more simpler substances is called decomposition reaction. So here it breaks, but in combination reaction it combines to form, means simple to complex. Combination reaction is simple to complex, but decomposition reaction is complex to simpler, like that of digestion. Digestion also what happens? Complex food breaks into simpler one. Whenever it breaks into simpler one. So decomposition reaction is a reaction of breaking up of substances. So here you can see AB on heating gives A plus B. That means the simpler substances are coming out. Okay, reactant. Now what is the tips? Or what is the way to know that the reaction is a decomposition reaction? Here the reactant has to be 1. Product can be of any number, but reactant has to be 1. But in combination reaction, reactants can be of any number, but product has to be 1. So just opposite. In combination reaction, A plus B was combining to give AB. Here AB is breaking into A and B. Since most of the decomposition reactions are carried out by heating, they are called thermal decomposition reactions. So thermal means heat. That means decomposition reaction needs heating. So those decomposition reactions which are carried out by using heat are thermal decomposition reaction. So all decomposition reactions are not thermal decomposition reactions, mind you. All decomposition reactions are not thermal decomposition reactions. Only those decomposition reactions which are carried out by heating, they are only thermal decomposition reactions, and most of the decomposition reaction takes place in presence of heat. That's why most of the decomposition reactions are thermal decomposition reactions. So similarly, decomposition reaction can also occur in three ways. Okay, a compound can break up to form two or more elements. A compound can break up to form two or more elements. This reaction is also called analysis. this reaction is also called analysis. That means analysis is opposite of synthesis. Analysis is opposite of synthesis. So why I'm saying analysis is opposite of synthesis? Because in synthesis, one element is combining with another element. Two elements are combining to form a compound. Two elements are combining to form a compound, then it becomes synthesis. But when a compound breaks into respective elements, a compound breaks up into respective elements, then it becomes analysis. It becomes analysis. So this reaction is also called analysis. So what is analysis then? Analysis is a decomposition reaction in which a compound breaks up to form two or more elements. So you can see example out here, mercuric oxide, HgO, mercuric oxide. When you heat mercuric oxide, when you apply fire on mercuric oxide, when you heat mercuric oxide, then mercuric oxide breaks into mercury and oxygen, So two elements we are getting, mercury and oxygen, hence it becomes analysis. Another example you can see, water on passing electricity. Now this decomposition of water into hydrogen and oxygen is not thermal decomposition. It is not thermal decomposition. Why? Because here we are not using heat, here we are using electricity. So this is electrolysis. What is this? Electrolysis. So what is electrolysis then? Electrolysis is a decomposition reaction in which a compound breaks up into different substances in presence of electricity. That means on passing electricity, a compound breaks into different substances, then it becomes electrolysis. Here water, on passing electricity through water, what is formed? Hydrogen gas and oxygen gas is formed, and the process is electrolysis of water. So this is also analysis. Mind you, the very important thing here to notice is whether a substance is breaking into two or more elements or not. There should not be any compound. If there is a compound, then it does not become analysis. Okay, it becomes decomposition reaction only. And then what is the thing to be noticed? First of all, you have to see whether the reactant is single or not. If the reactant is single, then it is decomposition reaction. If the reactant is not single, then it is not a decomposition reaction. That means to have a single reactant is the specific characteristic of a decomposition reaction. So the first way in which decomposition reaction takes place is a compound can break into two or more elements. Number two, a compound can break up to form both elements and compound as well, like that of a combination reaction, but just opposite. So what happened here is compound gives element plus element. A compound breaks to give element plus compound. Here potassium nitrate on heating breaks into potassium nitrite and oxygen. So potassium nitrite is a compound and oxygen is an element. Then number three is a compound can break up to form two or more new simpler compounds. So number three is a compound breaks into two or more new compounds. A compound gives compound plus compound. Calcium carbonate on heating at 100 degrees Celsius gives calcium oxide and carbon dioxide. Both of them are compounds. Then you can see here how decomposition reaction takes place on heating. Take some lead nitrate, a white solid, in a hard glass test tube and heat it for some time. You will observe that a reddish brown gas, can you see the reddish brown gas forming? This reddish brown gas is evolved, which turns moist blue litmus paper into red. So you can see this gas, okay, brown gas coming out, reddish brown gas coming up. And if you keep blue litmus, wet blue litmus, wet means first of all you have to dip litmus paper in water, and then you have to keep this litmus paper near the mouth of the test tube. Then you can see that when this gas comes in contact with this litmus paper, then the color of the litmus paper changes to red, which indicates that the gas that is coming out is acidic in nature. The gas that is coming out is acidic in nature. Also, a gas is evolved in which a glowing splinter bursts into flame. When heating is stopped, a pale yellow solid is left behind. So two types of gases will be formed. Number one is acidic gas. Will be formed which turns blue litmus into red, and another gas is also formed which helps in glowing. Means if you take the splinter, burning splinter means burning matchstick, then it will burst into flame. That means it helps in combustion, further combustion of the splinter. That means that must be oxygen gas, because oxygen gas helps in burning. And another which is acidic gas must be nitrogen dioxide. So a pale yellow solid, now when the heating is stopped, a pale yellow solid is left behind. The pale yellow solid is lead monoxide. The reddish brown gas is nitrogen dioxide, which is produced along with a colorless oxygen gas. So nitrogen dioxide gas is also forming, and then pale yellow lead monoxide is settled at the bottom. So you are heating only one substance, but you can see different characteristics. Okay, many substances with different characteristics are coming out, means it is breaking into different substances. It can be proved. So more examples of decomposition reactions are shown here. Potassium chlorate on heating gives potassium chloride plus oxygen. That means what type of decomposition reaction it is? A compound is breaking into compound and element. Number two, if you see a compound, copper hydroxide is breaking into copper oxide and water. Number three, copper carbonate on heating breaks into copper oxide and carbon dioxide. Number four, hydrogen peroxide on heating breaks into water and oxygen. There is no analysis reaction, mind you. In this out of these four examples, which one is analysis? Can you tell me? Yes, none of the reaction are analysis, because none of the reaction has products as elements only. There are at least one compound. Okay, but in analysis, both the elements, both the product has to be elements, then only it will become analysis. So that's it. Then hope you are doing your work also. Most probably I will give you the work. I'll solve the questions that is really very tough. So hope you are studying at your home. Stay safe, stay healthy, give time to your studies also. Thank you.